Yeah, that's right. All right, we are doing, oh yeah. We are working on our...
Picking noses?
Oh boy, this is a good start already. Okay, all right, 9.2. Here we go. All right.
Round 2.
I might have to pause. All right. Okay, so we are doing 2 truths and a lie in class this semester. I was curious to see if people put the lies in different places. And so I kept track. After 34 random students participated with replacements, I noticed that 18 picked the third option. Isn't that interesting? I don't know if this is going to work.
Peas? That's a peas?
Alright, I think I got rid of them. Alright, so, anyways, so it seems to me that people prefer the third option. But maybe, or putting their lie in the third option, maybe this is just a fluke accident, though. So, it says, use a significance level of 5% to do your test. Use the 4-step process. Alright, so 9.2 is all about doing a significance test or hypothesis test. And it's all about percentages. And so we kind of learned the basics over 9.1, and we're just going to start doing it. So, my statement. Alright. And here's what I'm going to put under my statement. Okay. I am actually going to physically write in here, I will perform a, let's make this a little smaller, a significance test to see if my classes use the third option more than first or second when playing 2 truths and a lie. Oh no, they're back. You better pause it and fix first because that doesn't have an R. Alright, there it is. Okay. Next, my plan. Oh, sorry. Also in this place, I need to put what my hypothesis is. So I'm going to put HO and I'm going to put an HA in. Alright. So this is all goes in kind of my statement. Now my HO is going to be, I think, the percent. What should the percent be? If there are 3 options, they all should be equal in option, right? So P should be at 1/3. Would you agree with that? If you can see that, that's a 3 right there. Should be 1/3. That 1/3 of the time it should be in third place. I, however, think that people are using this in a different. So I think the percent is going to be more than 1/3. This would be a one-tailed test. Alright. And for your convenience, I actually created a normal curve, right? This is where I should have most of my data. It should be centered around 0.33, right? But then I actually did a standard deviation for 34 people with P being 1/3. So I did this. Alright. Right, I did this whole thing. So it'd be 1/3 times the inverse of 1/3, which would be 2/3. All divided by 34, because I have 34 people. And this is how my data. I could get some stuff away from 0.333, right? And below. And this is kind of my representation, alright? Now it says I got 18 out of 34. So I'm going to hit that. 18 divided by 34. And it says I got a 59. So P hat my score was a, let's go 18. We'll just do this quick. Out of 34, which is a percent of 0.5294. Okay. All right, we're just getting everybody in this episode. Everybody's in this one. Yep. All right, so 52 is going to be somewhere around there. All right. So think of this. This is my hypothesis, right? This is my null hypothesis. Okay? Believing that 0.33 is true, is it possible to get this result way up there? All right. I'm going to usher these guys out. I'll be back in just a second. All right. So, the plan. I've got to write out the plan. Now, this is quite far away. Remember, this is the sample I got. The odds of getting that sample from a center of 0.33 is probably going to be rare, but let's figure this out. So the plan is my, is it normal? Is it normal? Is it random? Is it independent, right? Okay. And let's see, is it normal? And if I was to say anything, I would probably say yes. Yes, it is normal. Did I have 10 successes and 10 failures? Well, I had 18 people who picked the third option, which means I had 16 people who did not. 10 successes, 10 failures is a percent. So it is normal. I had 18 who picked the third option. And what did I say? 16 who didn't. Therefore, oh my goodness. Therefore, passing 10 successes and 10 fails. All right, that's my normal rule. All right, moving on. Is it random? I'm going to say yes. Stated 34 random. All right. Now here's the one. Random students, I should say. Here's the one that I'm not so sure about. Okay, we might, I don't know, maybe we'll have to branch this out in one more video. Independent. Now, if you think about it, as I'm removing people, I got less and less probability, right? I got to stay less than 10%. Is 34 less than 10% of the population? And, you might say, no, I think Mr. Sheevy has less than 340 students. However, notice up here it says with replacement, meaning I could pick the same person twice, right? I could pick them 3 times. So when I removed them, I put them back, therefore not changing the probability of the people I pick, because I could pick them again. Therefore, it is independent. This is an independent situation. Anytime I put back, it's always independent. So I'm going to say yes, this is an independent situation because I replaced each student. Okay, so anytime you put them back into the pool and are able to be selected again, you're not changing the probabilities. Right? If you have 52 cards and I pick one card, I would have 51 in the pile, but I put it back in, and so now there's 52 again. All right, independent. Let's fix that. All right, the next thing is my do. Now, you guys might have already seen my spoiler right here, and my spoiler is this is just a z-score problem. All right. So I think in this video we're just going to do one 4-step process, and the other ones we'll do a quick 4-step process. So the do here is what I got, which what I got was a p-value of 0.52 sorry, not p-value, a p-hat of 5294. All right, minus what I should get. All right, if everything was equal, I should have gotten a 33%. Okay, this is just a regular z-score divided by the standard deviation. Now, standard deviation is this guy, all right? And so I'm going to put really that whole thing. And, you know, I like, since I'm given a fraction of 1/3, I don't like to round that. I mean, I don't know how much off I would be if I did round it, but by putting the full fraction, you're not rounding, divided by 34. Okay, and this will find me my z-score. Okay, so I'm going to pause it, calculate my z-score, and I'll get right back at you. Okay, so when I calculated this, I got a z-score of 2.47. So that means I was located about 2.5 deviations above, which you can see by my graph that I already provided. I am 1, 2, and almost a half above. That's where my p-hat is. Okay, so now I'm going to look this up on my chart and see what's the probability of this event happening. All right, of being greater than. So 2.47. I believe I put 2.47. Be positive 2.4. 0, 1, 2, 3, 4, 5, 6, 7. All right, so it looks like it's that. Now remember, I am looking at the above section. So I want to reverse it. I want to go 1 minus 0.9932. And how much data does lie above that? 1 minus 0.9932. And I get about less than a 1%. Hold on here. Alright, I get my p-value. So my p-value, or the percentage that this would happen if the null was true, the percentage that I could have gotten that high result, I have about a 0.0068% chance of getting this result if this was true. So if my null hypothesis was true, I had a 1%, less than a 1% chance of getting the result I did. Now, those are really low odds. Really, really, really low odds, right? And notice up here it says we are going to use a significance level of 5%. So basically it says, hey, here's, I don't know where 5% is. 5%. It's going to be somewhere, I think somewhere around there, okay? If anything's lower than that, or if anything's in that area, we're going to reject, right? Meaning that's far enough away, okay? And so, remember, so my significance level is 5%. All right, and so there's that little jingle, remember? If my p-value is low, the null must go. And right now it is low. So my conclusion, all right, in conclusion, and let's turn this down to like 16. Conclude. In conclusion, there's an L somewhere. All right. In conclusion, I will reject the null. Okay, so right, if the p-value is low, the null must go. I'm going to reject the null. Odds are people don't prefer them all equally. Seems like the third option is higher. I will reject the null, meaning the third option to put a lie is preferred among my students. Period. All right, more examples to come.